This is the discrete calculator. It has specific functions for combinatorics in number theory. To consult the syntax and description of its functions, just press the interrogation button. Now I'm going to show you how to use the number theory and combinatorics functions. Let's start with GCD. We press on GCD, type 15 and 35, when pressing equals, we get the GCD. This can be combined with other operations and functions. The second function, pressing LCM, and typing 15 and 35, the result will be 105. The third function is pmod, which can be passed 2 or 3 parameters. If 2 are passed, it will calculate the remainder of dividing the first by the second. In this case the result is 2, since the remainder of dividing 7 by 5 is 2. If 3 parameters are passed, it will calculate the remainder of the division of the first to the power of second by the third. In this case 5555 to the power of 2222 divided by 7 leaves a remainder of 2. Now let's see the smod function. It calculates a solution to the equation a times x, congruent to b modulo c. To do this, press smod and enter 3 numbers and press equal to obtain the result. In this case, smod of 7, 2 and 9, we get 8 as an answer. Because 7 times 8 divided by 9 leaves a remainder of 2. And this can be verified using the pmod function. Now let's test Euler-Totient function. It calculates the number of coprime numbers between 1 and the number that was entered. In this case, Euler-Totient function of 9 is 6. The next function will solve a linear Diophantine equation of the type, ax plus by equals c. Placing the values of a, b and c in signed parentheses, as illustrated, when pressing the solve-line Diof button, the calculator returns the solution. In this case, the solution of the equation for x plus 18, y equals 10 is x equals minus 20 and y equals 5. The last number theory function is for factoring as a product of prime numbers. When typing a number or expression, if the result is an integer, when pressing the prime factors button, the calculator returns the answer as a product of prime factors. For example, 5040 is 2 to the 4th times 3 squared times 5 times 7. Now let's go to the combinatorics. The first is the function p, which calculates the number of permutations. P of 8 is 40,320. Whereas p of 8, 2, is 56. The second function is the PR, which is the number of permutations with repetitions. The first information is the total of elements and the others are the numbers of elements that repeat. In this case, PR of 8, 2 and 3 is 3,360. Now let's go to the C function that counts the number combinations. Let's calculate the number of combinations from 8 3 to 3. Typing C8 and 3, pressing equal, we get 56. The CR function counts the number of combinations with repetitions. Let's calculate CR from 35 3 to 3. The result is 7,770. The D function counts the number of derangements. In this case, D of 5 is 44. Now let's show how this calculator can help in the study of these areas. Let's calculate the problem known as the twin paradox in the case of 50 people. The problem asks to calculate the probability that given a group of n people, at least 2 of them have the same birthday. This can be calculated like this: 1 minus the p of 365 to 50 divided by 365 to the power of 50. The result is on the screen and is greater than 97%. This is just one of the many possibilities. Thank you for watching this far, and I hope this calculator will help you, whether in studying, preparing tests or correcting them.